Good morning, good afternoon, and good evening. This is Mr. Payne bringing you Unit 2, Lesson 6. More work with linear equations, talking about consecutive integers. One of the ways we can practice our ability to work with algebraic expressions and equations is to play around with problems that involve consecutive integers. Make sure you know what integers are. The integers and the consecutive integers. The integers are the subset of real numbers, -4, -3, -2, -1, 0, 1, 2, 3, 4. So positive and negative whole numbers. These are the numbers that you would see on a number line back in 3rd and 4th grade. That would be on the top of the board in your elementary classes. Consecutive integers are any list of integers, however long, that are separated by only one unit, such as 1, 2, 3, 5, 6, 7, 8, -4, -3, -2, -1, or -10, -9, -8, -7, -6. Those are all your consecutive integers, one right after another. Let's talk about consecutive evens. It's 4, 6, 8, or -8, -6, -4. They have to be in a row, and they have to be evens. Consecutive odds, 7, 9, 11, or -5, -3, -11, -1, and +1. Those are all your consecutive odds. Let's take a look at exercise number 1. Let's work with just two consecutive integers first. Say we have two consecutive integers whose sum is 11, less than 3 times the smaller integer. So it says here in A that it's important to play around with the problem numerically. So try a variety of combinations and see if you can find the correct pair of consecutive integers. We can go ahead and try that. Let's try the numbers 3 and 4 first. So the sum is 11 less than 3 times the smaller integer. So if we add them together, that would give me 7. And if we take 3 times the smaller integer, 3 times the smaller integer, be 3 times 3 is 9. And it says that it's 11 less than that. So 11 less than 9 would give me -2. That clearly is not the correct answer. So 3 and 4 is clearly not the correct. Let's try 14 and 15, or let's try 12 and 13. If I add those together, that's going to give me 25. If I multiply 12 times 3, it's going to give me 36. If I subtract 36 from 25, I'm going to get 11. So it is 36, or 25 is 11 less than 3 times 12. So therefore, 12 and 13 are my two consecutive integers. Let's go to B and prove that. We're going to do that by setting up a couple let statements. We're going to let x equal our first number, or our first integer. Then we're going to let x plus 1 equal our second integer. It says the sum of those, so x plus 1, is 11 less than 3 times the smaller. So 11 less than, the words less than right here are going to tell me to start at the back, so I'm going to start at 3 times the smaller. So 3 times the smaller, which is x, minus 11. Now all I have to do is my simple math, so x plus x is 2x, plus 1, which equals 3x minus 11. Minus 2x on both sides. Add 11 on both sides. X is going to equal 12. Not done yet. That's one consecutive integer. I have to now find the second consecutive integer by saying 12 plus 1, which gives me 13. So my two consecutive integers are 12 and 13. Exercise 2. I'm thinking of three consecutive odd integers. When I add the larger two, the result is 9 less than 3 times the smallest of them. What are the three consecutive odd integers? Well, the first thing we're going to do is set up our three let statements. So x plus 1, they're consecutive odd integers. Let me back that up. It's not going to be x plus 1. Forgot about that. So because we're thinking about consecutive odd integers, if I'm at 3, how do I get to 5? I have to add 2. If I'm at 3 and I want to get to 7, I have to add 4. So it's x is my first integer, x plus 2 is my second odd integer, and x plus 4 is my third odd integer. So it says when I add the larger two, so I'm going to say x plus 2 plus x plus 4, the result is 9 less than, so here we go again with the less than, we're going to start back here 3 times the smallest, so 3x minus 9. Same thing, do my basic arithmetic, x plus x is going to be 2x, 2 plus 4 is 6. And then continue to solve this equation just like you've learned. Minus 2x on both sides. Add 9 on both sides. X is going to give me 15. Is that an odd number? That's one way of checking. Is it an odd integer? Yes, it is. So now all we have to do is find my other integers. So I have 15 plus 2 gives me 17. So that's 1. And then I have 15 plus 4, which gives me 19. And that's my third odd integer. Exercise 3. Three consecutive even integers have the property that when the difference between the first and twice the second is found, the result is 8 more than the third. Find the three consecutive even integers. Well, that's the same thing. We're going to start off by saying my let statement's x plus 2, and x plus 4. It's not x plus 1 because if I'm at 2, how do I get to 4? I have to add 2. So that's why we're going to go up by 2. And notice that odds and evens are both the same. We're going to set this up by saying x minus 2 times x plus 2 equals, result is 8 more than the third. 8 more than means plus x plus 4. Go ahead and now distribute. Make sure that you're distributing the negative 2. So x minus 2x minus 4 equals 8 plus, let's go ahead and simplify that right away. 8 and 4 is 12, so I'm going to have x plus 12. X minus 2x is going to give me a negative x minus 4 equals x plus 12. I'm going to add x to both sides. So I'm going to have 2x plus 12 on that side, minus 12 on both sides. Negative 16 equals 2x, divide by 2, divide by 2. X is going to equal negative 8. Is that an even integer? Yes, it is. So let's find the other ones. So I have negative 8 plus 2, which is going to give me negative 6. Negative 8 plus 4, which is going to give me a negative 4. So my even integers are negative 8, negative 6, and negative 4. Exercise number 4. The sum of 4 consecutive integers. 4 consecutive integers is negative 18. What are the 4 integers? So I have x, x plus 1, x plus 2, and x plus 3 as my 4 consecutive integers. Let's add them all up. X plus 1 plus x plus 2 plus x plus 3 equals negative 18. 1, 2, 3, 4x. 1 plus 2 is 3 plus 3 is 6 equals negative 18. Minus 6 on both sides. 4x equals negative 24. Divide by 4. Divide by 4. X is going to equal negative 6. Now let's plug them in. Negative 6 plus 1 equals negative 5. Notice how I always circle my final answers. Negative 6 plus 2 equals negative 4. Negative 6 plus 3 equals negative 3. There are my 4 consecutive integers. Negative 3, negative 4, negative 5, negative 6. I hope that you understand a couple of the key concepts here between the consecutive evens and consecutive odd integers and how to create the let statements for these word problems. Have a great evening, and don't forget to write your WSQ.